Hello everyone, welcome back. Today we're delving into a topic that is both fascinating and terrifying. Could the sun, our life-giving star, truly destroy the Earth by 2025? Sounds like science fiction, right? But what if I told you this isn't just a crazy idea? What if the fate of our planet is inextricably linked to the burning core of our solar system? In this video, we'll look at the potential of the sun destroying Earth in 2025. Stay tuned as we look into the science and circumstances that could change our knowledge of the universe. Solar storms. Solar storms are eruptions on the sun that emit massive amounts of energy and charged particles. These particles can travel through space and interact with the Earth's magnetic field, creating a wide range of perturbations. Solar flares are the most common type of solar storm. Solar flares are abrupt blasts of light and energy that can linger for minutes or hours. They can cause radio and power outages, as well as satellite damage. Another type of solar storm is a coronal mass ejection, CME. CMEs are massive clouds of plasma released from the sun's corona. They can travel at rates of up to 3 million miles per hour and will take many days to reach Earth. When a solar storm strikes Earth, it can cause a number of issues, including power outages. CMEs can cause significant electric currents in power networks, resulting in widespread blackouts. Communication interruptions. Solar storms can potentially affect radio and satellite communication. Damage to satellites. Solar storms can damage or destroy satellites, potentially crippling our worldwide navigation and communication networks. Health risks. Astronauts and people working at high altitudes may also be at risk from solar storms. Understanding solar dynamics. Let us go deeper into the inner workings of the sun. It's more than simply a giant ball of fire. It's a dynamic celestial entity, and knowing its behavior is critical to solving the mysteries we're looking into today. But what precisely is going on beneath the surface, and how does it affect our planet? At its core, the sun is a fusion reactor in which hydrogen atoms combine to make helium, releasing massive amounts of energy. This process generates the light and heat that support life on Earth. However, the sun's surface is anything but calm. It's a tumultuous sea of hot plasma that is continually churning and bubbling. The sun follows an approximately 11-year cycle with periods of increasing and decreasing activity. At its peak, we see the solar maximum, which is distinguished by powerful solar flares and coronal mass ejections. These processes can propel high-energy particles toward our planet, resulting in breathtaking auroras, but also posing major threats. During the solar maximum, the sun can generate massive magnetic storms that produce solar flares and coronal mass ejections. These occurrences can send charged particles racing toward Earth at breakneck speeds. While they produce stunning auroras and exciting geomagnetic storms, they may also interfere with technology and threaten astronauts in space. So imagine a world in which these violent storms became the norm. What impact would it have on the Earth's climate, technology, and way of life? It's a question we'll go more into as we continue our exploration of this fascinating subject. The Carrington Event. The Carrington Event was a major solar storm that occurred on September 1st to 2nd, 1859. It was named for Richard Carrington, an English astronomer who witnessed a massive solar flare the day before the superstorm hit. The Carrington Event was the most powerful solar storm ever recorded, causing severe damage to telegraph networks around the world. Telegraph operators reported sparks flying from their apparatus, and some telegraph cables even caught fire. The Carrington Event also caused auroras to be visible as far south as the Caribbean. Auroras were so dazzling in certain regions that people believed the world was ending. If a solar storm of similar magnitude struck today, it may do catastrophic damage to our current infrastructure. Power grids, communication systems, and satellites might all sustain significant damage or destruction. The Carrington Event served as a wake-up call to the globe on the dangers of solar storms. Today, we are more aware of the dangers posed by solar storms and are taking precautions to preserve our infrastructure. However, we are still vulnerable to a Carrington-level solar storm, and it is critical to be prepared for such an occurrence. If you like it so far, click the subscribe button. Now let us proceed. The solar shutdown hypothesis. Now that we've established the sun's dynamic character, let's get into the heart of the matter, the solar shutdown idea. What is this idea, and why do some experts believe that 2025 could be a watershed moment in this context? The solar shutdown concept proposes that the sun may experience a period of limited activity similar to the historical Maunder minimum. This phenomena has been witnessed in the past and is distinguished by a considerable decrease in sunspot and solar flare activity. The Maunder minimum, which occurred between the late 17th and early 18th centuries, coincided with a period of worldwide cooling. This resulted in the Little Ice Age, characterized by harsh winters, failed crops, and social instability. So why are scientists concerned that a second solar shutdown may be imminent? While scientists cannot forecast the exact date of these occurrences, there are indications that our sun is entering a phase of low activity. If a solar shutdown happens, it might have serious consequences for our world. Cooler temperatures and its attendant issues may damage agriculture, cause food shortages, and exacerbate geopolitical tensions. Solar flares and the Earth's vulnerability. As we progress in our quest to grasp the potential threat from the sun, we come upon a critical piece of this intricate puzzle: solar flares and Earth's vulnerability. These flaming explosions are more than simply amazing exhibitions of cosmic force. They can have a significant influence on our planet and way of life. But how do they constitute a threat? Solar flares, which are abrupt bursts of energy and radiation from the sun, can emit massive amounts of energy. These eruptions include high-energy particles, X-rays, and ultraviolet light. When directed towards Earth, they have the potential to destroy our technology and infrastructure. Consider solar flares to be cosmic time bombs, capable of crippling our technological advances. We've had close calls before, such as the 1989 Quebec blackout triggered by a major solar storm, but the consequences of a direct hit might be considerably more devastating. Solar flares can cause electric currents to flow through power lines and pipelines, resulting in transformer damage and power outages. Satellite communication and navigation systems, including GPS, may be severely impacted. Consider a world without electricity or communication. This is a real possibility in the case of a big solar flare. Preparation and mitigation scientists and engineers are developing a number of solutions to protect our infrastructure from solar storms. For example, they are researching new technologies to protect power systems and spacecraft from solar radiation. They are also attempting to improve our infrastructure's resilience to solar storms, such as by implementing redundant systems and hardening essential components. Here are some concrete examples of technology and tactics being developed to safeguard our infrastructure against solar storms. Protecting power grids. Shielding devices can help protect power lines from solar storms. These gadgets can be used to redirect or absorb the energy of solar storms. Hardening satellites. Another option to defend our infrastructure against solar storms is to harden satellites. This can be accomplished by employing specialized materials and design techniques to make satellites more resistant to solar radiation. Using redundant systems. We may strengthen our infrastructure against solar storms by implementing redundant systems. For example, we can have many power lines and communication cables such that even if one is damaged, the others continue to work. Hardening essential components. We can also make our infrastructure more resistant to solar storms by hardening vital parts. For example, we can utilize surge protectors to protect sensitive electrical equipment. In addition to these technical solutions, we can safeguard our infrastructure against solar storms by improving warning systems and educating the public about the dangers of solar storms. By adopting these precautions, we can lower the likelihood of a big solar storm inflicting widespread damage to our infrastructure. Here are some steps you may take to protect your own home and property from solar storms. Prepare a backup plan for power outages and communication disruptions. This may involve having a generator, a battery-powered radio, and a flashlight. Keep vital documents and medications in a safe location. This could involve keeping them in a fireproof safe or using a cloud storage service. Make a strategy to evacuate your home if required. This could entail deciding on a safe location and having a plan for getting there. While the possibility of a significant solar storm in 2025 exists, it is crucial to note that scientists are working on strategies to decrease the hazards. We can do a lot to defend our world from disaster readiness to space research. Remember that, while the sun's ability to destroy Earth in 2025 is a fascinating concept, it is not a guarantee of doom. Instead, let us use this information to motivate action and ensure our planet's future. If you enjoyed this exploration as much as we did, click the next video displayed on the screen. I'm confident you'll enjoy it. Thanks for watching.